Howdy everyone, welcome back for a second video. So this is part 2 of the Mini 3020 CNC build. Last video we had a look at the machine itself, tore apart the control box and found out that we need to replace the fake control board in there that is only functioning at the moment with a few demo versions of old software that to get the actual licenses for would mean that we would need to buy the official boards for them, which would be a very expensive endeavour. We're looking for a much more budget friendly open source way of doing it. From the minutes of research that I've done, maybe hours, maybe days, what's that among friends, I've been really digging deep into ways that this can be solved, ways that we can sort this problem out and install something new into the machine that can then run, simple as that. And there seems to be that you could go with the official kind of Planet CNC boards or other various control boards. There's millions, hundreds of thousands of different ways that we could do this. Different machines, CNC machines run off different architectures, and it's kind of it's a very complicated new world that I'm not overly used to. I'm excited to learn more about, but I think I've settled on, or at least for this video I've settled on, the simplicity of going with GRBL, which is a open source kind of firmware that will run the machine. It will drive everything, and it should be fine. It should work. Other people have got videos out there and information out there and walkthroughs out there of how to do it for many different methods of doing it. So I dug around on eBay and Amazon and all other good online retailers are available, and I came across a couple of potential ideas of how I can get this to work. So let's have a look at them. And so after minutes of research and a little bit of time spent figuring out which way I wanted to run with this, I came across two different control boards that I thought looked reasonable, price-wise and also quality-wise, and ones that I'd seen other people have had success with to varying levels in the past. The first is a 2-win GRBL 1.1. This is the upgraded board, whatever that might mean. I think it mainly means it's got its own independent power switch and maybe the cooling fan as well. Comes in a nice little case with all these header pins for the different sections, which is quite nice. Also comes with a nice little printed instruction sheet, which is always a pleasure whenever you're working with these kind of things. Correction, that's for the Disassembly board, this one here. So a similar idea, slightly bigger board with different components and different layout, I guess. It comes with a small stick-on heat sinks and a nice instruction set, which I think should help us with this as well. There is an online instruction set available with this. So I need to choose a board, install the board, see if it works, and I've got a spare board for when I inevitably do something stupid or damage what I already have. So, in order to connect to these, we need to pin into the machine, which also means I've then had to go through and look at options for splicing and pinning things together. So let's have a look at them. So the issue I am facing is that these 4 pin connectors here are too large to go into our stepper connections here. An easy enough fix, we're going to have to either change the ends of this, which I suppose we could possibly do actually, or we can splice the cables together. So I'm going to have an explore and see what my options are. I'll get back to you in a second. And so then began an adventure into finding the right connector. I took the board that I was trying to use, left over here. Took the board, I took the pins here, I measured between the pins. It's not focusing very well, that is it. But I measured between these pins, and then that was a measurement of 2mm. I thought, excellent. A little bit of the old Google foo. Came across a nice pack on Amazon of connections. Thought brilliant. It has 2 pins, 4 pins, 6 pins, all the different different sizes that we need. They arrived a few days later, and they were too small. I'd messed up. and misunderstood. Quite a simple thing to do. What I'd done, in fact, let me show you. Right, so this is the board that I decided we're going to install. This is the 2-win GRBL 1.1 upgraded board. It just looks like a nice little board to work on for now. I will keep the other one as a reserve. But what I had done when measuring the connection points for these JSTs, which is a Japanese solderless terminal connection, often used in small part electronics, I was looking for these 4 pins here, which is the 4 pins for the X motor, Y motor, and Z motor. So essentially the motors that are going to drive our CNC machine forwards, backwards, left, right, up, down. So I'd measured the distance between these pins at about, it came out at approximately 2.1 millimeters. And what that meant was that I assumed that this, between the two of here, was the indicator of pitch. However, I was wrong. So I bought these connectors, which turned out to be far too small. It's not the end of the world. They can sit in my components box for a while. So from there, I moved to buying a kit of connectors. I came across these and found out after a second measurement, where I was measuring from the pin centers, so right from the center of one pin to the next pin, gives you the pitch of the pins. It kind of makes sense when you think about it. But there we go. I made a mistake. I wasted a few pounds on some cables I don't particularly have a use for at the moment. So I got this lovely little connection kit here, which will allow me to either reattach the wires that are already in there, or splice onto and input these into the next one. So the next step, I guess, is start to rip out the old board and start to put in the new and see how that goes.
So here I am, taking apart and figuring out how the board comes out, bit by bit, screw by screw. Finally realising there were 2 more screws on the bottom.
So that initial phase wasn't too terrible. So we can see here we've got our X, Y, and Z axis controls. These are the pins that we need to have a look at the headers for. Some various other things. We've taken the power, and halfway through I realised I could just take off the whole heatsink, which was only held down by 2 of these screws. Whether we're going to reuse this heatsink or not, I'm unsure. I mean, if we could make mounting points, I suppose it would help this stay cool, or if we could somehow mount this in, but we'll have a look at that in a little bit. So that was very successful. We've now got everything unconnected. Maybe just need to change these headers round. Need to sort out the power header as well, because the old power is on just a sort of standard pin plug, whereas the power for this new device is a power socket. You can see here, power socket. This is the USB to connect to the control computer. This is the power in socket. So I need to take the pins off of this, which is a, let's have a look, it's a drive power supply. That should be the right voltage. We'll find out. And then we're going to wire it into this little connector, which then slots nicely into that end connection. You can see gives us the power connection that we need. So onto those stages. Right, so just a quick bit of an explanation of how these connectors actually function. So you get different kinds. Some have these smaller headers have little clippy bits that clip in. So when it clips, when you put in, it's got little runners on the back of the header here, that as they run in, lock into place. Other ones have these really nice sort of strong clip connections on them, just to hold them in place. But all you have to do is just pinch that clip, pull it off, and there you go. You've got a loose header. And these wires feed into this header, and then you can see there's little tiny clips in here. Let me see if I can find focus. There we go. little tiny clips in here, and to get them out you can see that if you move the header just up and down a little, they are actually loose in there, but all they're doing is when the pin goes through, there's little crimped on terminals that grab onto the pin on the board and make a complete connection and complete a circuit. So to get these out, I've had to go rooting round and steal my wife's tweezers, which I'm sure she'll be more than thrilled with. So I can't find the ones in my workshop. And then you just push this forward. Once these are pushed forward, you're going to push the pin down with a little bit of force, and it should just slide straight out. And you can see there, that's the terminal that the pin slides into when it goes through the end, and it grabs onto and completes the circuit. So we're just going to repeat this on this side, and then we can get this wired into our power supply. So they are now free and ready to go. Whether I'm going to be able to get these in, we're going to have a look. So join me over at the workbench and we'll have a proper look at these. Okay, so these are our connectors. You can see, if we look really carefully, if I do this, we can see how they have a small clip around the copper wire here. Can I pull focus onto these? I can just about. A small clip on our copper wire, which then is making contact with this whole shroud above it. This shroud above it then gives us our pin-in terminal. Now, we're going to take this and we are going to put it in here. In the end of here, we can see we have little screws that clamp down with our positive and negative. I know on this, I think the blue is the positive and the black is the negative, but we will check that before we wire it up. And so we need to get something that will fit into these terminals. As it currently stands, these are not a great fit. They will not fit nicely into those terminals. So we might have to take these off. Or what I'm hoping I might be able to do is kind of cut the ends of these off with a pair of pliers, and then this flat bit then might actually go in. Let's have a go. Okay, so the first cutters I managed to find were these big cutters, but they fit very nicely into that jaw, and let's just take that off. And then you can see we still have a nice clip connection on there, meaning we're going to have a very nice complete sort of circuit connection. And that should, in theory, fit very nicely into this. Might need a little bit of fiddling. Ooh, it doesn't quite. You can see the cuts kind of a little bit rough, so we're just going to grab something and just file that down. So just a touch of a small file. On each side, I'll just take off those burrs. And then hopefully that'll fit nicely, as I predicted, into those terminals. Yeah, so very happy with that. Rinse and repeat with the other one, and put it all together. They fit really nicely in there and should snug down really nicely with those screws. So that plan didn't quite work out, as these particular pins, when you tighten them up, as you can see here, it is pushing this plate down, and so this was pushing out those terminal connections. So next step of the plan is to strip them. Simple, easy, and will work happily, nicely with the connection. So these then just feed into this terminal connection, screw down, and we're ready to go. Then I've just got to work out the rest of it. Let's get on with this. And there we go. One connector complete, going from the pin out on the board into our top. So the blue is the positive, coming into the little positive symbol here, and then the negative returning back to the ground and power source there. So that's now all ready to go. Just got to go through the rest of the connections, and then we should be able to just plug it in, get it all working.
So many fiddly little connectors. Ah!
Right, so after some fiddling, these pins were definitely too big to go in our new board. So I have removed the wires from these, hoping that the little off-cut pins were going to be compatible potentially with a chocolate block. They weren't, but that is not the end of the world. Just chop the ends off, strip the wires, and attached on our new pins, which then are the correct size to slot nicely into this board. He says, having the dexterity of an elephant, unable to actually get it in, but believe me when I say they do fit. There we go. That's starting to go in there. Don't want to commit to it because I'm going to have a struggle getting it back out. But we're coming from the old run wide into a chocolate block, keeping a, well, not quite consistent colour system, but we can at least trace our wiring to the green being the negative and the yellow being the positive. I've chosen to go a little bit out of the usual wiring options because in terms of colour, because I have a limited set of these and want to keep the other colours for various other blocks that I might need. These are never really going to be changed again. The only thing that might happen is that these might get properly soldered together and tidied up once we've got it right. We've got 2 positives, 2 negatives on here. So one will be feeding for the forward action of each of the motors and one for the reverse as well. So I'm concerned that maybe the pin out on the new board might be slightly different. Hopefully they should be the same. I can't see why they wouldn't be the same really. But at least by using this small terminal chocolate block, we can switch and swap if we need to. So now I've just got to do that 2 more times, and then hopefully it should be time to get the board fired up.
And so then began the great task of unpinning all the rest of the connectors, wiring up new ones, putting in chocolate blocks, and getting it all so that it connects through. It was all going absolutely swimmingly, making all the little routes up at the bottom you can see that then I was going to feed into the machine. Around about this point here, you'll see me thinking, hang on a minute, these colours look different. Oh, no, I've wired them all back to front. So comparing and rebuilding them all. Had to do them all again. Have fun. But all in all, I really enjoyed the process. It wasn't too bad. And now I'm a pretty dab hand at getting the pins out of these connectors and putting them back in. So let's have a look, review the work that got done, and we'll get on to the next stage. Let's go!
And so there we go. Out with the old JP382C clone board, and in with our new control board. All wired in, ready to be tested and powered up. So we will get the computer over here now, and we'll just do a quick test to see if we can jog and move our CNC using our new control board. Let's have a go. And we have power. Success, perhaps. We'll find out shortly. So I've plugged this in, we've got the power plugged in here, the USB's plugged in, everything else is plugged in. It seems to be passing power through to it alright. We've connected it up to the open build control, which looks like a nice sort of basic control set. And it's instigated straight away a very slow download due to the power of the Wi-Fi in here. A very slow download of an update. So I'm just going to let that run through, and then we'll see if we can jog it round, move it round, do anything with what we've got. But so far it's looking like a raving success. So once again, out with the old, in with the new. Let's see how this goes. And so there it is. It's now communicating. It's picked us up. We've managed to connect to the control board, and if I am to hit the jog buttons, which I can use the arrow keys down here for, we can hear motors beginning to move. So we can move it left and right, and we can currently move it forwards and backwards, and up and down. So that shows us that we're getting communication, the correct communication. Then what we can do here is we can send it to a predefined 0 point. So when I hit this button in 3, 2, 1, it's going to reset it to a 0 that we've just set up. So that's going to find a point that we're happy with. There we go. And then we also have the option here. I've loaded in a very simple circle program. So when I hit the run job button up here, this is going to run that job, and what it should do is draw us a nice little circle. So to start going to its point, it would be now be down in the machine and running round, cutting, and then homes itself once again. So that's it. We're done. It's working. I'm happy, very happy. And that's the first step of the progress. We've changed the control board in the machine. It is now communicating with the software that we can use to run programs and make things. Quite simple as that. I've got a whole other bunch of ideas of how I can do upgrades to the machine, including some little limit switches and various alterations like that. But all in all, it's a thumbs up. It's progress. I'm really happy with how we've got on so far with just getting it communicated. I'm not the biggest knowledgeable person about electrical items. I know as much as I know and have to struggle my way through the rest. But thanks for watching this video. I hope it's been interesting. So, from the workshop, that's it from me. I hope you're all having a great time out there. Go out there and make things, everyone. Make wonderful, beautiful things. Share them with me. I want to see what you're up to. What projects have you got on? I want to see. Bye bye.